continue to introduce the chapter. But anyway, again, we're doing chapter 8, part 3, and we're starting off elasticity as an economic application of total differential. So, class, what do we mean by elasticity again?
From what I can remember, is that like the change of profits after changing one variable, for example, the price of the commodity?
Yes, that is correct. So we when we talk about the law of demand and law of supply class, you know that there was a direction, the change of direction when any of these variables changes. Like for example, if there's a change in price and you're concerned with how consumers would react, you know that they would decrease their consumption. But again, you know the direction, you know where it would lead on. Like for example, if there is change in price, if there is an increase in that price, you know that the direction when it comes to the producer side, there would be an increase as well in their production because again, prices are signals for them to increase their production. Now, but the thing about that scenario is that by how much that change when the price of a good rises or fall. And so you know the direction, but you don't know the magnitude of that change. So the approach that we use to answer this question is again to calculate the elasticity of demand or the elasticity of supply of the good in question. So when you talk about elasticity, again, it provides a technique for estimating the response of one variable to changes in some other variable, and it has a lot of application in economics. So again, when we just refer the word elasticity, it talks about responsiveness. Responsiveness, please. So again, what we mean responsiveness, it means that again, if there's a change in the price, how would consumers react? And obviously, they would react in a way that they would they would consume less of that good. But again, we are concerned of with we're concerned of with the magnitude. Like for example, if there is an increase of price by 10%, let's just say let's put 10% here. Yeah, if there's an increase in price of 10%, then quantity demand will decrease by what percentage? Okay, so this magnitude is very important because as what Kawana mentioned last time, it does translate to total revenue. Okay, so again, obviously total revenue is price times quantity, and so if you are a producer, if you increase your price by 10%, then what do you think would you think that the decrease in the consumption would be greater than or less than that increase in the prices itself? So just an overview class, if consumers are very responsive to the price change, we call we call the good very elastic, meaning that we know that the consumers are very responsive to the price changes. So elasticity or their factors where we talk about that there are factors that that allows us to understand the elasticity better. So goods that are very elastic in nature, these are necessities versus luxuries. So for example, when those goods are considered as a necessity, then they are a bit more inelastic. So let me just organize this one. So inelastic, right? So again, these two terms are what we always refer to when it comes to elasticity. So let me just define first. Again, when we talk about elastic goods, these are goods that our consumers are very responsive to the price changes. When you talk about inelastic goods, these are again goods that on the other hand, consumers are not that responsive. So there was a response in terms of less consumption, but it's not really that drastic compared to again having elastic goods. So again, what are those factors that just tries to determine whether the good is elastic or inelastic? One is when the good is a necessity versus a luxury. So if it's a necessity class, it is more inelastic. When you talk about a luxury, it's more on elastic. So another factor is that when the good has a lot of substitutes, it means that the good can be considered as more elastic because consumers will find more alternatives. Like for example, I'll just probably name a few goods. So if there is increase in the price of Coke, people will look for alternatives. And in the Philippines, there's a lot of alternatives for that, which is again, generally we call that one sugar sweet beverages. And so if there's an increase in Coke, people would probably what's the alternative? Probably would look for a Pepsi or RC Cola, which again, which made a name, which made a quite made a headline probably this year. So in that case, the more goods or the more the good has substitutes or alternatives, then it is more elastic. Okay, and so again, these are just factors that determines whether the good is elastic or inelastic. But let's just take caution class that not all goods seem appear to be elastic because again, it's a critical question if the good itself is universal na elastic siya. Kasi it really depends on the person. It depends on obviously if the country is developing or developing or developed. Like again, these these two factors does differ from these scenarios. Okay, so again, our topic for today is what we call price elasticity of demand. So specifically, which is price elasticity of demand. And so when we talk about price elasticity of demand, it again measures the responsiveness. I'll just write it here. So it measures right here. So it measures the responsiveness of quantity demand of a product or a good, let's call this one good, to a change in the price of that product. Now, why I specified on this point, because again, there are other price elasticity stats or there are other elasticities in study. Like for example, this one, which we will be focusing on, the price elasticity of demand. We also have cross price elasticity that tries to determine whether the good are substitutes or complements. We also have income elasticity. So when we talk about income elasticity, again, it refers to whether the good is an inferior or a normal good. And we also have price elasticity of supply. So again, there are other elasticities in study, but as an application for total differential, we'll just focus onto this one. Okay, so since I mentioned that one on the side, I'll just then put this one on it also. So what are other elasticities in question? Elasticity. So we have again price elasticity of demand. We also have income elasticity. We have cross price elasticity again. Price elasticity, and we have price elasticity of supply. Okay, so again, income refers to whether the good is an inferior or a normal good. Again, just a review, when you talk about inferior goods, it means that if there is an increase in your income, these would likely be the good that you would consume less or you would consume not much. So when you have a normal good, this is the good wherein if there is an increase in your income, you would buy more of this good because the idea there is that you have this much income already and you can probably afford now to purchase this good. We have cross price elasticity. Again, we talk about substitutes and or complements. Or sometimes we have a neutral good when you neutral. So um, when you talk about substitutes, again, these are alternatives goods. When you talk about complements, then complements is that if there is an increase, you use it together. When you have a neutral good, it means that these neutral good, yeah. When you have a neutral good, it means that these goods doesn't have any relationship at all. Okay, so and we also have what we call price elasticity of supply, which on the side of suppliers already, wherein if there is price increases, how elastic producers are when there are changes in the price. Okay, so again, just concerning of our topic for today, we'll only tackle one, which is again the price elasticity of demand. So let's going back to that slide here. Okay, so now in your introduction to the discussion on elasticity, you are introduced um, to this kind of formula. It's a midpoint formula in computing elasticity. So I'll just write it down quickly again so that it can help you remember what are those variables that we are in study for price sensitive demand. So again, that was okay. So that's delta Q. So again, if you still remember class, so that's delta Q, which is the and Q, and we also have delta. Delta, yeah, okay, and we also have delta P, delta P there, delta P, delta. Okay, so right. So again, back in your introductory for elasticity, there we are using first the midpoint method. So again, we have a percentage change here in Q, which is a ratio of the changes in Q and the average of Q over the changes in P and also over its P average. So again, we have here, so getting the price sensitive demand using the midpoint method is just, sorry, it's just the change in Q over the change in P there. And also how do we interpret the price elasticity? Again, it is understandable, class, that the price elasticity of demand is always a negative because, again, it's if you're making some trade-offs, you need to increase one. If you're making trade-offs, it means that in order to get one good, you need to or if there is an increase in prices, we have a decrease in consumption. So again, a negative price elasticity of demand is natural, or again, it's understandable because it's price and quantity, they have this inverse relationship. Okay, and so in um, in interpreting the price elasticity of demand, so again, if it's so when the price elasticity of demand is greater than one, okay, we call that good elastic good. Again, you can get the absolute value for this one because again, anyway, it is understandable that it would be a negative. Okay, so elastic good. elastic good, and again, if it is equal than one, equal to one, you have which is one, which is again unit elastic. So when you talk about unit elastic class, it means that let's just say if there is a price increase by 10%, unit elastic. So unit elastic means that if there's an increase by 10%, the quantity demand also would decrease by the same percentage, which is also 10%. Okay. So when you have when the price elasticity of demand is less than one, okay, so this would now be less than one, then you know that the good is an inelastic good. Okay. Now, again, as I mentioned last time, why is it important that we know if the good is inelastic, unit elastic, or elastic? Again, on the side of a producer, if you would be, if you are deciding whether to increase your prices, and then you have to know what good you, what, you have to know what the good is. Like for example, if you are again increasing the price and your good is an your good is an elastic good. So again, if your good is an elastic good, you know that your total revenue would decrease because again consumers are very responsive to that price changes. However, if your good is considered as an inelastic good, again, these are the goods that consumers are not really that responsive. So in result, the total revenue would increase if your good is in inelastic good. So since we're talking anyway about this category for elasticity here, let's give some examples. Okay, so I already mentioned Coke as an example for elastic goods. In this case, this is just by theory, so let's talk more about an elastic good. Uh, Anyone who would like to provide examples of what are those goods that are considered as inelastic goods? Anyone? What are goods that are inelastic in nature, or not in nature, but in study? Or what do you think are goods that are considered as inelastic? So again, these are goods that the consumers are not really that responsive. Anyone? What are those goods that are considered as inelastic? Megan, can I call you? Yes.
Hello po, ma'am. For me po, kasi nagte-take po ako ng, medicine for my asthma po. So, I think it's
Mm.
inelastic po in a way. Kasi kahit, nagbabago po yung price, I wouldn't be that responsive po.
That's
Kasi,
yeah,
it's a necessity po for my part.
yes, that's a good example. For again, medicines test again, we go back to what are those factors that try to determine whether the good is elastic or inelastic, and medicines are part of that. They don't have that much substitutes, and also they're considered as a necessity. So right now, also there was a study class. There was a study that it tries to determine which are those goods which again are inelastic in nature. And for one, almost imperfectly, yeah, almost perfectly inelastic good is insulin. So the reason for that one is that there was no close substitutes at all, and at the same time, it's considered as a necessity for those people who are then who needs that who needs an access to that good. So universally, those goods are considered as insulin as considered as a perfectly very close to a definition of a perfectly inelastic good. So we also have question. We also have suggestion. We also have question answers here. Petroleum. I as petroleum, Juano, may I ask, why do you think that petroleum would be considered or is an inelastic good?
I think considering that there aren't that much alternatives like yung mga electric cars, it's not that yet parang popular here. So I feel like if tataas man yung price ng petroleum, people have no choice but to still buy it because it's for transportation, it's to transport goods and other stuff. No?
Yes, that is correct. So, if you look at an historical basis task now, if you look at again oil shocks, you know that it really had an impact onto the economy, and so in this market, also specifically petroleum, there is really no substitutes for that, or we are still probably in the process of looking for one, I suppose. Perhaps in this at the present time it might still be considered as an inelastic good, but in the future, as more technologies are being developed and there's uh, uh, advanced innovation, probably we can have another step of finding an alternative for that, so that we will not be dependent onto this market. We also have one answer, rice. Artatas, why do you think rice is considered as an inelastic good? Yes, Artatas, why do you think rice is considered as an inelastic good? Okay. Rice. Because it's a staple food. Yes. Yes. We go back to the to again. So those factors, if it's a necessity, it is can be um yeah, it can be an inelastic one. But this would probably could stem a lot of contestation, or meaning or some arguments, because a lot of people might again it's a very personal, it's a very individual thing when it comes to elasticity, because other people can live without rice, other people can look for substitutes, like for example kamote, and some sorts. But now that I think about looking for alternatives for rice, it's a bit difficult. Difficult kasi, I'm actually imagining right now because so, on like, sisig with, sisig with bread, or sisig with kamote, lechon with kamote. Not really an ideal combo. We really need rice for that one. So, but anyway, yeah, this could be some examples of an elastic good. But there's also another inelastic good tests that have been heavily studied in the literature. So, recently around 2017, 2016, yeah, around that time, there was what we call a syntax law. So syntax law is a tax on sugar sweet beverages and also alcohol and also cigarettes. But based on that study, the government really did generated a lot of revenue for that one, for those foods, because they increase, there was an increase in their taxes, and so you know that there was an increase in tax, it would translate to an increase in the prices, but the consumption of those goods were quite were expectedly not that drastic. So therefore, total revenue, there was a generation of revenue for that point. So again, cigarettes and alcohol, and also some sugar sweet. I would be specific on sugar. I would be specific on cigarettes. So it was a good health response. I would say it was a good health policy, I believe, and also a revenue generating policy, I would say. But again, cigarettes, it's an inelastic good. So again, even if before, the price of cigarettes, like for example, pula puti, it was around 120, 2 pesos, 3 pesos. Now it's 5. People did not stop consuming people did not stop consuming cigarettes. Okay, but I'm not pretty sure for alcohol and these days because there were a lot of liquor bans recently, so that it might have been affected to the nature of that. But people might be starting to realize that there are other alternatives to that. But in terms of cigarettes, I'm pretty much sure that it's still considered as an inelastic good. Okay, now again going back to our discussion. So in that case, class, as when we go back to this one, again, we know that there's a change in the variables of Q and P here. So again, just relating it to total differential. Again, so we have elasticity here, elasticity. So we can also know that we just did it some part here. So it means that when we have when we have this function y is a function of x here, then just again, we're now relating elasticity to total differential, then that getting the elasticity would be equal to this. Like B, yeah, I'll put that one on the side, yung formula ng midpoint, so that you can check dy, dy, and we also have dx. Okay, so let me put that one on the side. Okay, so again, from the midpoint formula for elasticity, again, that is the percentage change of Q over the percentage change in price. So you know that that Q is a function of price. So if Q is a function of price, then we can relate it where Y, generally, Y is a function of X. And so getting the elasticity would mean getting the ratio of dy over Y over dx over X. Again, when we go back to the midpoint formula for elasticity, Q here is a function of price. So when we look at it again in general, Y is a function of X. Therefore, elasticity or the price elasticity of demand would be a ratio of a change in Y over Y over a change of X over X. So let me just rewrite this one. Now, again, writing it in a more compact way, it would look like this. Dy dx. Okay. So again, getting the ratio of the change of y over y and the change of x over y, writing it in a more compact way. To get the price elasticity, you have dy over dx multiplied by the ratio x and y. So putting again on the side, how do we make this one more appropriate to the price elasticity of demand? So it would we can rewrite it this way. So that's the right. So again, how we kind of just again relate. This is probably again how we relate the concept of total differential to that of elasticity. So again, class, we started off that Q here is a function of price itself, and then we get the ratio, and also we write it in a more compact way, and therefore relating it to price elasticity. ED, or getting price resistive demand, is now dQ over dP multiplied by the ratio of price times quantity. So again, this now would be our standard way, a standard way of getting elasticities. So as an example, let me just get my notes and um, get the price elasticity directly from a demand function. So for a while. Okay. All right. So again, I will just be using an example from the book. So this is again, this is you can follow at page 184, right? So okay, put this one on the side. Okay. So again, if you have when you have this function here, where q is equal to 100 minus 2p 2p plus 0.02y 100 minus 2p plus 0.02y. Okay, so when you have this demand function, and we also specify that p here, I'll put this one on the side para we won't confuse. So and p is equal to 20, and also y is equal to 5,000. Okay, I'll put these on the side because as you know me, I put things on the side just for me, just a guide. So again, our formula or how we can solve the price elasticity is by using this. Again, a ratio of dq over a change in q and a change of p multiplied by the ratio of price and quantity over quantity. So our values have also specified where p is equal to 20 and y is equal to 5,000. So in the case here is that we will need to look for the price elasticity of demand. So again, using the equation, we can just simply again input those numbers on our function here. So ED now again, which is equal to this would be -2. Okay, so y -2 plus again dq over dp. This is just getting the first derivative of p here. So that's with respect to a partial derivative, partial q, partial p, or getting the derivative here, which is again equal to -2. We also have 20 dq. So that's 20 over 160 for a while. Let me just get my calculator for a while, class. Okay, so going back, so that's again -2. You take dq over dp here, and then price again as this is already given, so that's 20. How did we arrive with 160? So again, just substituting the values from this function, so that's 100 minus 2 minus 2 times 20 plus 0.02 times 5,000, which is again y here, and you'll get a value for q which is equal to 160. Okay. And so when simplifying here, our elasticity of demand would be equal to negative 0.025. And so again, class, how do we interpret this one? Again, it is understandable. This again only applies for price elasticity of demand because it is understandable that it will always have a negative value given the inverse relationship of price and quantity here. So the price elasticity of demand here is negative 0.25, which means that this is lesser than, again, we get the absolute value here. And this would only apply to price elasticity of demand. So that is that is okay. So that's so this would now be equal to 0.025. Okay, so that means that the good is or the demand here is inelastic. So the price change here means that the change in price is greater than the percentage change in the quantity demand. So again, this is lesser than zero, which means to say that if there is an increase of price by 1%, the quantity demand will decrease by 0.25%. Okay. Now, you can again, what so question test, I feel like I'm a bit too fast in the discussion. Question about how did we arrive with the value of 0.25? Which part do you want me to go over? Sige, I'll just briefly go into yung pagkuha po ng 0.25. Okay, so again, we have a formula, we have an equation for price elasticity, which is again a ratio of dq over dp multiplied by p times q. Okay, so we started here. And then our demand function here is equal to q is equal to 100 minus 2p plus 0.02y. So the first thing you'll need to do, because again, there are values that need to be substituted, substitute y, which is equal to 5,000 into the demand to our demand function here, and it will give you, okay, I'll put this one on the side, it will give you a value of q which is equal to 160. Okay. Now, because you already have your values here, the next thing to do is to substitute the values into our elasticity of price elasticity of demand equation, which gives you this one. So how did we arrive with negative 2? dq over dp, again, partial q, partial p. You get the first partial derivative with respect to p here, and so you get, again, negative 2. So that's negative 2 over p, which is 20, and over 160. So how did you get, saan po nakuha yung 160? So again, 160 is, okay, let me just complete this one. So that's p is equal to 20, 0.2. Okay, is this correct? Oh. Okay, here. So here's a complete picture of what we did. Again, this is a bit disorganized already. Okay, here. So how did we arrive with 160? This is how we got 160. Okay. So other questions? Okay. Now, actually, guys, so the next thing to do here is we will need to determine also total revenue. Now, I will need to, can we have a question? Again, -2 is coming from partial p, partial q, partial p. So you get the first partial derivative of the original function, and you get a -2. So that's how we get -2. Okay. So going back to what I said earlier, the next thing to do when we're getting elasticity here is to get also the total revenue. Now, we only have 3 meeting staff for lectures or 2 meeting staff for lectures. So I decided not to already, and instead on focusing on other things. Okay. So, but again, the next thing to always do here is to get total revenue. But this is again just an application. We have one more application for total differential. So I will not choose anymore to discuss total revenue here. Okay. So I think I will just go to another topic already, a subtopic. Okay. So in the exam, I would probably give you one question about elasticity. And again, all you need to remember is how we arrive with this equation for a price elasticity of demand. Okay, so if there's no other question on how we arrive to these values, I'll go to another topic which again uses chain rule. So I'll use a clean file. So this is already number 2. Okay, total differential. All right. Now, last meeting, again, we had a discussion. Total differential is again this one here. It's the general way to do it, and okay, let's have an example test. Okay, so sorry, I'll use this one. Okay, I'll put this one on the side. Just adjust a guide. Okay, so this is our total differential. Now, this was only possible because when you look at our values test, when you look at our function, y is directly a function of x sub 1 and x sub 2. But there are actually cases where we there's actually cases wherein these values as well is also a function of other variables. Okay, say for example this one here. So suppose we have this function. Okay, so when we have z, let's have z. Okay, so we have z x squared, squared. Let's start first with again just with this example, x squared plus y. Okay, so let's first start with this function here. So z is equal to x squared plus y squared. So you know that getting the total differential, it means that we are just getting dz. Okay, so and which is dz that is partial. I think I'll just use this one. Okay, for what kasi? Okay, so use this one. So this would be dz, partial x, and this would be x, and also partial f partial y. This would be dy. All right. So again, when you have this function z is equal to x squared plus y squared, you know that getting the total differential would be equal to partial f partial x multiplied by the change in x plus partial f partial y plus dy. So again, it's really not that complicated. Now, you can also extend to this one, again, because we have our values there. So we have dz is equal to what is partial f partial x? So that would be 2x times the change in x, which is dx, plus partial f partial y, which is also 2y, times dy. So again, total differential of that of z again is equal. Okay, I'll just delete this one because we already have our total differential here. So again, getting the total differential of z is just getting partial f partial x multiplied by change in x plus partial f partial y multiplied by dy. And so we have this total differential of z. Now, again, this in this case, class, it's not really that complicated because we can just go ahead and write the total differential of dz again in terms of dx and dy. But the complication starts to come in when x itself and y, so let me just write on the side here. So the complication comes in when x, on the other hand, will now be equal to x is equal to u squared. So we have u squared minus v squared. Okay, so again, x is equal to u squared minus v squared. And let's also have y, but we can have a complete picture. So y is equal to uv. Okay, so again, the first thing that we did earlier was to write the total differential dz in terms of dx and dy. And again, it's not really that complicated. But if you are confronted with this one, class, where again x is also equal to u squared minus v squared and y is equal to uv, the question here is that how do we find partial z partial z, and then we also have partial u. Okay, so now you will need to get partial z, partial u. So I'll just put this one as a highlight because again, this is important. Okay, and then so on this side. Okay, here. So again, how will you get partial z, partial u? So you cannot possibly, it is, there's actually two methods to do this, class. Let's start first. Let's put this one on the side. Yeah. So again, we will need to find partial. I'll put this one on the side. Okay, so just to clarify my point there of what we're trying to do here. So we will need to find partial z, partial u. Okay, so there are two ways to do it, two methods to do it. Method one. So I'll put this one also on the side, or I won't be confused. Okay, also. Okay, so right, so method one is you get all total differentials of z, you get the total differential of x, you also get the total differential of y. So I'll just copy this one on the side because we already have an answer for dz. We'll now look for dx and dy. Okay, so so that's method one. You get first the total differential of z, x, and y. Okay, we also have dx as well. So what is the total differential of dx? So dx, again, we look at the function, we look at the equation for dx. So that's this is 2u, 2u, tapos du, and what is this one? V. Okay, so 2v dv. Okay, so class, is it clear how we arrive dx? Is it clear? Again, it is just the same process as just like what we did earlier, but now we're doing it for x. Okay, so the total differential of dx is again just by following this one here. So that's partial f partial u, which is 2u multiplied by the change in u plus partial f partial v, which is 2v multiplied to the change of v, which is dv. Is it clear on how we arrive with dx, or the total differential of x? Okay, I hope that's clear. So the next thing to do now is to get the total differential of y. Okay, so you see it's a bit, if you want to explore this method, you can, but as you can see here, it's a bit parang, it's a bit lengthy, or no. So let's solve for the total differential of y. So y here is y is equal to uv. Okay, right, good. Thank you for correcting. Let me just go back to that one. So this is supposed to be a negative. Okay, here we go. So that's 2u du dv. All right, good. Thank you, Omega. So let's proceed to dy. So dy, that would be equal to v du. This is the positive, so that's v du u dv. Okay, is it correct? Okay, this is v v u u. Okay, I think that's correct. Okay, so for method 1, to get partial z partial u, you need to first get all the total differentials of z, x, and y, and so that's how we that's how we arrive to those numbers. So the next thing to do is you will need to do substitution this time. So I'll put this one onto the right, just to focus on what I'll do on the left side here. Okay, so we have our total differential of x here. We also have our total differential of y on the side as well. So the next thing that I will do is to substitute the values here to these total differential here. Okay, so in that case, this will now be equal to, okay, I'll just copy. This will now be equal to, so that would be dz is equal to 2x and 2u. Okay, I'll just emphasize. So that's 2u du minus dv dv plus 2y. Just cheat that's okay here. I think that would be it. Okay, so all right, I hope you can still see the organization of this one here. So again, what happened is that we substituted these values, we substituted the total differential of x and y into the total differential of z, and we have 2x, again, substitute the change in x, which is again the total differential, which is our approximation, which is equal to 2u du minus dv dv plus 2y multiplied by the change in y, which is our total differential of y here, which is v du plus u dv. And so to simplify, class, this we simplify the total differential of c into equal to this one. So that will be dz, that is 4x. So all have the values for okay, so we'll have 4x u plus okay. 2 dv for a while, class, okay. So again, simplifying this, class, would be equal to your total differential, which is equal to 4x y plus dvy multiplied again to du plus 2y minus 4xv dv. So again, this we kind of we just really simplified, or yeah, we just simplified here, coming from the values for the values here. Okay, so if you take a closer look, class, tz here, okay, so that's just partial just partial z, partial z, partial z, partial u times pu plus partial z and u du, tapos partial z, and then we also have partial v just t. Okay, all right. So in that case, class, this in general is just partial z, partial u. This in general is just partial z and partial v. Okay, so again, the partial z, partial u, again, is just equal to this one here. But because our method allows us to get the total differential of z, again, it's also we also got the entire values for total differential. Okay, so let me just go ahead and check if I have the correct values. So that's partial C. Okay, good. That's correct. Okay. So now for method one class, again, it really demands you to have these, to really explore on first getting all the total differentials and then substituting it to values to do, sorry, getting it to the total values and then simplifying it to get the total differential of z, where you were only asked, but the thing is, it's quite a lengthy process, but you're only asked to get partial z, partial u, which is again 4x or x2v, 4x v, for a while plus of 4x, 4x 2v, partial z, partial x. Partial c, partial u. Okay, great. This is supposed to be ux. Okay, so that with for u. Okay, good. I think that's clear. Okay, so again, class, you're asked here to only find for partial z, partial u, which is again this one here, but the method allows you to get the total differential of z. But again, it can save you time if you can find another way, another direct method. I would say just to look for these partial z, partial u. Okay, so method two now is a more compact way. It now uses the chain rule. So if you are reminded with what the chain rule is in your Math 100, again, it's quite of the same concept here, but it will kind of use dependency graph. So in Shang's book, there was an illustration. I actually forgot the page number, but there was an illustration there. Yeah, let me just show quickly because I think I had that one on my lecture notes. Stop